Hello everyone. Hello everyone. So far we have discussed about the module 1, introduction to the real-time system, and what are the computer controls are there in the real-time system we have talked about in the previous video. Now we are going to talk about the module 2. In this module, what we are going to talk is the computer hardware requirements for real-time applications. So far we have talked about what is the real-time system, what are the classifications, what are the program classifications, general classifications of real-time system, and what are the controllings are there in the real-time system we have talked about, right? So now what we are going to talk is what are the hardwares are required for real-time applications. So this is what we are going to talk in this entire module. So in this module we are going to talk about the introductions of the computer hardware requirements, and the general purpose computer, single chip microcontroller, and microcontroller and microcomputer, and specialized processor related interfaces, and data transfer techniques, communication and standard interfaces. Okay, so the first we are going to talk about is introductions of real-time systems. So in this introduction what we are going to talk is what is why the hardwares are required for real-time application, what are the hardwares are required. Okay, so generally the computer is very much required. So the general purpose microcomputer, which includes the Intel 86 series, and also a 68 series, and national 32-bit series, and also a Zilog 2 Z80, and also Z8000 series. So these are the microprocessor series which is there. Okay, now any of the digital computer that can be used for real-time computer control, and that is for the specify the real-time operation, they are not easily adopted. Okay, adaptations is very much important in this. Okay, and in the majority of embedded computer based systems, the computer used may be a microprocessor, or it may be a microcontroller, or it may be a specialized processor, or some kind of a digital signal processor. Okay, so the specialized digital signal processor, which includes the fast digital signal processor and parallel computer, and also a special disk processor. Okay, so according to this, these are the microcontrollers are there. Okay, and they are modular, and adding the extra units to it, that is peripheral devices in a particular specialized input output devices to the basic unit. So the capabilities of this basic unit in terms of its processing power, storage capacity, and input output bandwidth and interrupt structure determines the overall performance of the system. Okay, so that input output channel which provides the means of connecting the process instruments to the computer, and also displays and the input devices which is provided for the operations. Okay, so this is what there in this general purpose computer. And okay, so the next what we are going to talk is the general purpose computer. So we know that in general purpose computer we have a general purpose register, and also a arithmetic logic unit and control unit. So combined this is called nothing but a central processing unit, and the main memory, input output interfaces, and peripheral devices. Apart from this, the data buses. So the data bus, control bus, and also address bus. So these are the things are there. So now what we are going to do is we are going to talk about in detail about all the processing units. Okay, so the first one is the central processing unit. So in the central processing unit, the combination of ALU, control unit, and general purpose register, which makes the CPU. So central processing unit. So to process that we need some kind of a purpose register. I mean the arithmetic logic unit which is required, and control units are required, and general purpose registers are required to store the data. So all the things which is nothing but the CPU. Okay, so what is ALU? ALU is nothing but an arithmetic logic unit which carries out arithmetic and logical operation. Associated with it may hardware units to provide the multiplication and the device of the fixed point numbers, and in more powerful computer and a floating point arithmetic units. Okay, and general purpose register. So we know that general purpose register is nothing but a temporary storage register. So that temporary storage register, it is used to store the temporary data. Early computer which had the limited GPRS, general purpose register. Nowadays the large system may have as many as 256 register. Okay, so we can use a main memory, or otherwise we can use a fast processing unit for this general purpose registers. And the control units. So control units continuously supervise the operations within the CPU. It fetches the program instructions and set up the necessary path and timing cycle for executions of the instruction. Okay, so the features of the CPU which determines its a processing power are the word length, instruction set, addressing methods, and number of register, information transfer rates, and interrupt structures. Okay, now the computer length is an important in both in ensuring the adequate processing precision and also the calculations, and in allowing the direct access to large data of the main storage within a one instruction cycle. So what are the basic instruction sets of CPU, and it's also very much important to determine overall performance of the system. So that features which describes the flexible addressing modes for the direct and immediate address and relative addressing mode, and address modifications by the use of index register, and the instruction to transfer the variable length, the block of data between the storage units, or the location within a memory, and also the single command to carry out the multiple operation. So these are the features which is reduce the number of instructions required to perform the housekeeping operations, and hence both reduce the storage requirements and improve the overall speed of the operations by reducing the number of access to the main memory. However, the efficient programming in assembly becomes difficult with a complex instruction set. And when I come to the storage device, there are two categories. One is the fast access storage and another one is the auxiliary storage. So the fast access storage is a part of the system which contains the data, program and result which are currently is being operated on the RAM, ROM and also a PROM and then EPROM for the storage of critical code and predefined function. And ROM provides the protection against the loss of program through the power failure or corruption by the malfunctions of the software. So alternative to use the ROM, which is usage of the memory mapping techniques and the trapped instruction which attempts to store in a protected area. Okay, so the auxiliary storage medium is typically a disk or magnetic tape. So that provides the bulk storage for program and data which are required infrequently at much low cost. So the longer access time needs for interfacing and software operates asynchronous to the CPU. So here the one more thing is DMA. DMA is nothing but a direct memory access. That method is frequently which is used. And when I come to this input-output systems, so the input-output interfaces is one of the most complex area of the computer system due to the variety of device and variations in the rate of data transfer. So the printer operates at 300 rate of bond generally. Okay, so that disk may require the rate of 500 kilobytes. Okay, so the input-output subsystem is divided into three sections. One is the process I/O and operation I/O and computer I/O. Okay, so these are the three input-output structures are there in this input-output subsystem. And the next is bus structure. So the bus structure which is characterized by the mechanical structure and also electrical structure and the functional structure. Okay, so these are the three ways of the bus structures are mechanical. Mechanical structure is nothing but the physical structure, and electrical, and another one is the functional. Okay, so the mechanical structure, it's nothing but the buses are collections of conductor which carry the electrical signals. Okay, so that electrical structure which is nothing but the buses are the signal level and loading and types of the output gates. And the function structures that describes the type of the information in which the electrical signals flowing along the bus conductors. Okay, so these bus lines can be divided into three functional groups. One is the address line, and another one is a data line, and another one is a control and status line. Okay, so this address line which provides the information on where the information is to be sent, and then data line which specifies what the information is, and control and status line indicates when it to be sent. So these are the things which is related to this bus structure. Okay, so the mechanical terms, the bus is a collection of conductor which carries the electrical signal. For example, tracking of the tracks on the PCB are wishes in the ribbon cable. The physical form which represents the mechanical characteristics, and the electrical characteristics is nothing but the bus or the signal level, that loading, how many number of nodes and then line can be support, and type of the output gates, open collector and also a tri-state driver. So the function characteristic which describes the type of the information which the electrical signal flowing along the bus conductor which represents, and that could be divided into 3 functional groups, that is called data line, data line, and control, and then status lines. Okay, where to send, what to send, and when to send. So this is all about your structures of the general purpose computer.